Good day, everyone. Today, we are going to learn about scale and how we can use it to interpret and compare distances. Let us begin with a question. Look at the three examples shown here: a map, a blueprint, and a sketch. The map represents places and distances. The blueprint represents the layout of a house. And the sketch represents an actual object. Notice that the measurements shown in these drawings are not necessarily the actual measurements in real life. So, here's our question. How can we determine the actual distance represented by a distance on a map, blueprint, or sketch? Think about that question first. What information would we need in order to make that conversion? By the end of our lesson, you should be able to explain what a scale represents. Interpret scales presented in maps, blueprints, and sketches. Determine actual distances when you are given a distance on a drawing. Work in the opposite direction, determine a drawing distance when the actual distance is given. And finally, you should be able to compare distances using a given scale. Now let's answer our earlier question. A scale shows the relationship between a distance on a drawing and the corresponding actual distance. For example, consider the scale 1 to 100. This means that 1 unit on the drawing represents 100 units in reality. If we are measuring in centimeters, then 1 centimeter on the drawing represents 100 centimeters in reality. So whenever you see a scale, the first thing you should ask yourself is, what does 1 unit on the drawing represent in actual distance? Once we understand that relationship, we can calculate the actual distance. Let's apply that idea to this blueprint. The scale is 1 to 100. That means every 1 centimeter on the blueprint represents 100 centimeters in the actual house. The table helps us see the pattern. 1 centimeter represents 100 centimeters. 2 centimeters represent 200 centimeters. 5 centimeters represent 500 centimeters. And 6 centimeters represent 600 centimeters. In this example, the measured distance on the blueprint is 5 centimeters. So we multiply 5 by 100. That gives us 500 centimeters. Since 100 centimeters is equal to 1 meter, 500 centimeters is equal to 5 meters. Therefore, the actual distance represented by 5 centimeters on the blueprint is 5 meters. Now let's see how scale works on a map. The map has a scale of 1 to 50,000. The distance between town A and town B on the map is 4 centimeters. Because 1 centimeter represents 50,000 centimeters in reality, we multiply 4 by 50,000. That gives us 200,000 centimeters. Now we convert that to meters. That is 2,000 meters. And 2,000 meters is equal to 2 kilometers. Therefore, the actual distance between town A and town B is 2 kilometers. Let's move from maps to blueprints. This blueprint uses a scale of 1 to 100. The wall shown here measures 6 centimeters on the blueprint. So we multiply 6 centimeters by 100. That gives us 600 centimeters. Converting 600 centimeters to meters gives us 6 meters. Therefore, the actual length of this wall is 6 meters. Notice that the process is the same. We interpret the scale, multiply the drawing distance by the scale factor, and then convert the answer to an appropriate unit. Scale is also useful when we draw objects. Here, the sketch of a table uses the scale 1 centimeter equals 25 centimeters. The length shown on the sketch is 5.5 centimeters. To determine the actual length, we multiply 5.5 by 25. That gives us 137.5 centimeters. So the actual length represented by 5.5 centimeters on this sketch is 137.5 centimeters. The important idea is that the same process works even though we are now dealing with a sketch of an object instead of a map or a blueprint. Now that we know how to determine actual distances, we can use scale to compare them. Here, we have 2 routes on the same map. The scale is 1 to 10,000. Route A measures 3 centimeters, while Route B measures 4.5 centimeters. For Route A, 3 centimeters multiplied by 10,000 gives 30,000 centimeters, or 300 meters, which is 0.3 kilometer. For route B, 4.5 centimeters multiplied by 10,000 gives 45,000 centimeters, or 450 meters, which is 0.45 kilometer. Now we can compare them. Route B is longer than Route A. The difference is 150 meters, or 0.15 kilometer. So scale allows us not only to determine actual distances but also to make meaningful comparisons between them. Let's summarize what we have learned. A scale tells us the relationship between a distance shown on a drawing and the corresponding actual distance. Before calculating, we need to interpret the scale correctly. We also need to keep our units consistent. When the drawing distance and scale factor are given, we use multiplication to determine the actual distance. When the actual distance is given and we need to find the drawing distance, we use division. And when two or more distances use the same scale, we can compare them directly after determining their actual values. Finally, we should always include the appropriate unit in our answer. Before we end, let's connect what we learned to real life. Think about situations where you might use scale. For example, if you are planning a trip, a map can help you estimate how far you need to travel. If you are designing a house, a blueprint can represent the actual dimensions of rooms and walls. If you are arranging furniture, a scaled drawing can help you determine whether an object will fit in a particular space. So scale allows us to represent real-world distances in a manageable form and then use those representations to make practical decisions. Excellent work today. Thank you for participating.